So right now I am going to go over genetic algorithms for trading, and this might be a long project, so strap in, but I'm gonna show you absolutely everything that I learned and everything I know. And yeah, so I'm gonna type out this prompt. I'm gonna use ChatGPT for all of the great coders out there that hate me for using this. I love you too. So I'm gonna use ChatGPT here, and I have a bunch of screenshots here and a transcript here. Above is a transcript to one of my teammates' walkthrough of genetic genetic algos. I also included all of the code that was provided in the screenshots. I want you to go step by step to explain the entire transcript and all of the code that goes along with it. Make sure to go over all of the code so that I can copy it and then run it on my VSC. So your goal is to teach me back everything above. Yep, that's it. This is perfect. This is perfect. Life is perfect. I'm so glad that you're here. Okay, so let's bring over our code over here, and we're just gonna go ahead here and say folder v VGEs VGE, and then we're gonna say vid1.py. There's like 12 vids, so we got a lot to go over, and this is stuff that I'm still trying to comprehend. But at the end of the day, genetic algorithms, we've done our own little testing on them. But as I mentioned before, I worked with a researcher for almost a year on this stuff, and it was way over my head. So I feel like I am now 3 years deeper, or at least 2 years deeper. I don't know. Anyways, genetic algorithms are inspired by Darwin's theory of evolution. They are used to find optimal solutions by mimicking processes such as selection, crossover, and mutation. In algorithmic trading, these algorithms help in optimizing trading strategies by evolving potential solutions over generations. The transcript describes a genetic algorithm for optimizing trading strategies. It includes concepts such as genotype, phenotype, crossover, and mutation, and explains how these are applied in the context of trading. Population and individuals. A population is a group of potential solutions. Each individual in the population has a genotype, a list of integers representing parameters. Genotype and phenotype. Genotype is a list of integers like 23, 65, 32, and so on. The phenotype is the actual parameters derived from the genotype, which are used to evaluate the individual's performance. The fitness function evaluates how good an individual trading strategy is based on metrics such as Sharpe ratio, drawdown, and ROI. Crossover and mutation. Crossover, combining parts of two parent solutions to create offspring. Mutation, introducing random changes to an individual to maintain diversity. So let's go over this code step by step. Let's go ahead and let's put all of this in there because I feel like this is I'm walking through these research with GPT. Okay, that looks better. Now let's walk through all the code here. This is pretty simple stuff. I'm not going to spend any time on it. Just a bunch of imports. Backtrader, I don't even have Backtrader in here. It's amazing. Give me the transcript, please. Just downloading the transcript. So like I mentioned, I hired a researcher a couple years back. It was way ahead of me and still way ahead of me in this game. So it was actually pretty hard to understand what the heck he was talking about, but it's part of the game, And that's what's great about this is that now we can understand it. Dang, I can't get the subtitles off that one though. Okay, that's fine. It looks fine. Why can't I get the subtitles off it? Subtitle YouTube. Don't say it. Don't say it. They don't like it. They don't like what I'm doing right now. Gotcha. Gotcha. Perfect. So where should I put this? I should put it in the in here so we have it, the README here. Okay. So this is just a bullet point overview. I think this is the same one. Yep. Perfect. I was like reading this yesterday. This is the transcript of the first video. All right, that's the transcript. Okay. So below is the transcript to the video my teammate was teaching me about these GAs. Please go over everything and reteach it to me from what was said in the video. Also, go through all the code in the pictures. So I can then copy the code and run it. Below is the code we have so far that came from the video prior to this. Please teach me everything and give me all code so I can learn. Okay, so let's give it the all this code. And now I need to give it all the images. So what should I call this? I'm gonna call this section 1, vid 1 and 2. Vid 1 and 2. Okay, so let's go ahead and get all of the images out of here. of the code. So where did we stop? We started at KPI. Perfect. Perfect. So that's screenshot 1 here. I love AI, dude. This is so insane. I literally wasn't able to understand this, but now I can because we have AI. It's insane, dude. Where did we get to here on this one? So we got down to Cerebro.add analyzers, trades, and Sharp. Get them out of here. Get them all out of here. Longs and shorts. Wreck everybody. Please. Leave only algorithmic traders. I'm sorry. If they watching right now and they're still trading by hand, come on, blood. Okay, so we're down to there. Perfect. Dude, you don't understand how much time and effort this man put into this. So I'm excited to get his whole brain. And I'm excited to watch this stuff back, to be honest. Because me plus AI explaining this is way better. I mean, not that like I'm a good explainer or I'm good at this, but the at least you can understand my accent, kind of, hopefully. Okay, so we got down to here, which is awesome. Not that one. I want this one. So we're gonna have all the code by the end of this. So we got down to 10, N10, Npop 10. I've also got some papers we need to go over to really fully understand this stuff. I'm doing the hard things people aren't gonna do, dude. So, you know, this is not easy stuff, and it's not expected that anybody understands this because I don't. But with time, I for sure will. That's the great thing about life, dude. The great thing about life. You just keep going, bro. Keep going. Do hard things every day. If your day's not hard, you're not living. Just straight up, B. Straight up. KPDF. How you gonna switch on me like that, cousin? That's funny. Switch over to Kaggle. Sick, bro. Okay, so do we have everything here now? Yes. We do. Okay, now I want to go ahead and key up these papers here. So let's go ahead here and say recommended paper recs. Dude, we have everything. There's literally only things between you and I and absolutely taking over this world is time. So keep coming back. I'm gonna keep bringing the ideas. Most of them are gonna be trash. Let's be honest. Most ideas are gonna be trash, but that's okay. It's okay. If you don't understand why, then that's okay too. All right, we got paper recommendations here. We're gonna go over those next. You got any questions? Throw them in the chat. Are those frames from a YouTube video? Nah. Cheesecake says, if you use genetic algorithms to data mine, please use the permutation test in the book by Tim Masters, Permutation and Randomization Test for Trading, because it's very easy to overfit. The test will also allow you to save your output of sample data for something that you find is worth it. Nice. Oh, dope. Thanks, Cheesecake. Hey, KW, what up? 777. See, Silvio's in Tokyo? Dude, have a great day. Or night. Whatever, wherever it is. Whatever time it is there. Have a great everything. Have a great life, bro. All right, let's go ahead here and read through it. Let's break down the entire genetic algorithm step by step, including all necessary code snippets, and explain each part. So these are the imports. We already went through these. This is the strategy. We already went through that. This is getting the getting phenotype here. So we got phenotypes, we got genotypes. This gets the KPIs. Okay, let's get all of it. It's all in there. Cool. And then here, the rest of the code sets up and runs the genetic algorithm using the deep library. These are for my teammate. He made videos for me to try to get my peanut brain to understand things, but my peanut brain is a little slow. You know how that goes. So I took screenshots of the video. So the rest sets up the genetic algorithm from the deep library. Evaluate. So you can see evaluate uses golf here. Let's go through the additional code segments shown in the screenshots. This part of the code defines a function to calculate the KPIs. Okay, I need to update this. Get KPIs here. Def get KPIs. Paste that in. This segment of the code trains the genetic algorithm using defined KPIs. Continue, blood. Curious to see like what they say, because again, I had somebody help me with this before AI was here. So like, who's behind is the question, or who's ahead? Yeah, that's what I'm curious about. Like, is one better than the other? Main. Safe eval. So please teach me everything from both compare and contrast, and then come to a conclusion on which is better to focus on, the VGA or the MGA. Okay, perfect. Let's say comparing and contrast. Comparing dot MD. Yeah, that does stand for MoonDev, bro. Sakar says, I have nothing to do with this stuff, but I don't know why I'm still watching you doing this. By the way, I'm a developer too. I do .NET. Okay. I also trade Forex. Sakar, I don't really like you that much. I don't know why you're watching this either. I just say that because you said, why don't you learn how to trade? for sure make more money than algo trading. I don't agree with you at all. So I don't know why you're watching this either. I don't like you. I love you. But yeah, I don't know why you're still watching. I don't know why you're still watching, dude. You should get Ghost. Get Casper on them, bro. Come on. It's your time. It's your time to go now. It's good to have you, bro. Every single day I go live. VGA. Continue, cousin. So let's go ahead and read through this. I guess I'm comparing genetic algorithms to grammatical evolution too. That's kind of stupid of me, but my bad. In this comparison, we have two genetic algorithms used for optimizing trading strategies, VGA and MGA. Both are designed to enhance trading strategies by iteratively refining parameters to achieve better performance metrics like Sharpe ratio, drawdown, and return on investment. Let's walk through their components, differences, similarities, and overall conclusions. VGA, which is your team's GA. The overview is the VGA uses Backtrader for backtesting and Deep for genetic algorithm implementation. It focuses on optimizing a predefined trading strategy using technical indicators. Key components: it loads the data, reads data, sets up training, validation, and test folds, uses the fold size to split data. Strategy definition: the Gulf strategy uses Stoke RSI, the whole QQE, and ATR indicators. Headphones died. My headphones died. Strategy definition, okay, indicator, phenotype conversion. Converts genotype, which is random integers, to a phenotype, which strategy parameters, using predefined ranges and modulo operations. Fitness evaluation, uses Backtrader to run the strategy and evaluate performance metrics. Genetic algorithm setup defines fitness, individual, and population, registers crossover, mutation, and selection functions. Uses EAMU plus lambda algorithm to evolve the population. Results collection. Stores the best solution and evaluates it over the training, validation, and test data. The MGA. The MGA uses mathematical expressions to find defined trading strategies and evaluate them using backtesting. It involves multiple scripts, evolution, all these scripts. Key components: grammar-based strategy generation, using GrammarFile to generate random trading strategies as mathematical expressions involving indicators, operators, and functions. Ensures the generated expressions are valid using safe evaluation functions, safe eval. Fitness evaluation. Evaluate strategies using backtests to compute Sharpe ratio, number of trades, and return percentage. Evaluation functions. Tournament style selection. Selects the best individuals for crossover based on fitness. Crossover combines parts of two parent strategies to create new ones. Mutate randomly alters parts of a strategy to introduce variation. Evolve population manages the overall process of generating new populations. The main execution manages the entire process of generating initial population, evaluate strategies, evolving the population, and logging results. So the comparison of the VGA and the MGA. Similarities: genetic algorithm structure. Both use selection, crossover, and mutation to evolve the population. Both aim to optimize training strategies based on performance metrics. The fitness evaluation. Both use backtesting frameworks to evaluate the performance of trading strategies, use of random initialization, both initialize the population with random strategies or parameters. Differences, strategy representation, the VGA predefined strategy with placeholders for parameters optimized by the GA. The MGA randomly generated mathematical expressions representing strategies. Indicator use, the VGA uses technical indicators such as Stochastic RSI, the whole QQE, ATR, uses a broader range of indicators and mathematical functions. The evaluation function directly uses backtrader strategies, uses safe evaluation function to handle mathematical expressions safely. Grammar-based generation uses a grammar file to ensure generated strategies are valid. This one does not use a grammar file. It uses on optimizing predefined strategies. Multiprocessing incorporates multiprocessing for parallel evaluation. Does not explicitly mention multiprocessing, but could be integrated similarly. Which one's better? VGA is more structured and easier to understand if you have a clear predefined strategy and specific parameters to optimize. It leverages technical indicators directly and is simpler in terms of implementation and modifications. MGA offers more flexibility and creativity. 1 and 1. The reward defined as the change in portfolio value, accounting for transaction costs. Turbulence threshold measures extreme market movements to avoid risks from sudden events. Other parameters, initial capital, maximum shares per trade, and reward scaling factor. The framework at LSTM extracts features from stock data, and PPO uses these features for decision making. The system updates parameters through gradient descent. LSTM as feature extractor utilizes LSTM's memory property to capture time-dependent features in stock data. The PPO, which is proximal policy optimization, optimizes policies through stochastic gradient descent using clipped surrogate objective functions to stabilize training. The model's performance is evaluated on US and Chinese stocks. The dataset includes 30 stocks. Key parameters for training include reward discount factor, update frequency, and learning rate. The proposed model is compared to the S&P 500. Evaluation metrics are CR, max earnings, max pullback, average profitability per trade, and Sharpe ratio. The best parameters for the LSTM window and hidden size in PPO are determined through experiments. The proposed model outperforms baseline models in terms of cumulative return and Sharpe ratio. The model shows even greater advantages in the Chinese market, with significantly higher cumulative returns and Sharpe compared to the baseline models. The paper concludes with that the proposed DRL-based stock trading system using Cascade LSTM networks is effective in capturing profitable patterns in stock data. The model shows strong performance, particularly in emerging markets like China. Future improvements could involve increasing training data and optimizing the reward function. So in our context, these are the key takeaways. State representation. Use relevant features like technical indicators and market conditions. Modeling approach. Combining LSTM for feature extraction with a robust RL algorithm like PPO. Optimization and hyperparameters. Conduct experiments to determine the best parameters for your models. Evaluation metrics. Use comprehensive metrics to evaluate trading performance, including risk-adjusted measures like Sharpe ratio. So we can know what's going on in this paper a little bit. Get them all the way over there. There we go. Comparing this with your GAs, VGA versus MGA. VGA and MGA sub both use genetic algorithms for optimization, but different evaluation and mutation method. State and feature extraction. Consider incorporating LSTM or other feature extraction methods to enhance your GA models. Optimization techniques leverage advanced RL techniques like PBO in your decision making in your GAs. That might be interesting. So that was a lot. And let me answer any questions here. I'm trying to implement one, but I can't choose between parsing CoinGecko or Dex's APIs. Yeah, dude. The choice is yours. I use Bird Eye. Much love to everybody.